Hello everyone. In this lecture we're going to take a look at some of the potential impacts of climate change on farm systems and delve into a little bit more detail about adaptation and mitigation strategies that can be implemented on farm to manage some of the impacts of climate change and hopefully reduce some of the effects. So I'm going to talk for a little while and cover a range of topics, including sort of a quick overview. Let's go and take a quick look at what climate change is, how it happens, and obviously what the size of the impact of climate change is at this moment in time on Welsh agricultural systems. We look at a little bit more about some of the sources of greenhouse gas emissions within farm systems. Most of these, I imagine, won't be a surprise to you. It's quite common knowledge these days where a lot of the greenhouse gas emissions come from, but we'll recap on those. So as when we come back to talk about adaptation and mitigation strategies, there's a little bit of context there. And then, as I say, we'll then go into the detail about how to adapt a farm landscape, i.e. to change it so as it can manage with the climate change effects or to mitigate some of the effects of climate change. Actions that can be implemented on farm which actively reduce some of the size of the potential impact. So, climate change. Well, at this stage, it is an effect which is unequivocal. It is having an impact. We know that it is a consequence of mankind's activities, in essence, that we are emitting carbon or other greenhouse gases to the atmosphere, which are impacting on global average temperatures and consequently on our weather and climate systems. The easiest way to think about it is the globe is essentially an energy flow. The more energy you stuff into it, the more unpredictable it's going to become. And if you can imagine the amount of heat is essentially energy. The more energy in the system, the more unpredictable the system, the greater the effect of things like, for instance, weather events or the likelihood that they will occur. The headline figures are in front of you, but I think the thing that's important to recognise is that we are warming now at a rate which is unprecedented. We are going year on year higher and higher, and we are getting to the point now where we're talking about warming that hasn't been seen in the last 800,000 years, and there's a graph in a second which will highlight that fact. I think it's worth at this stage just very quickly touching on what climate change is, or how we understand that climate change is an effect, because there's always conjecture, there's always a voice somewhere which says it's not really happening, or that the data's not complete. That really isn't the case. There is absolute consensus in the scientific community at this stage. 97% of all scientists agree, or at least all climate scientists agree, that this is something that is absolutely happening. That, I would suggest, is an overwhelming consensus. What the graph here essentially shows is that 4 major meteorological organisations from around the globe, 2 in America, us and Japan, are in absolute agreement as to what the historic temperature record is and the trajectory of change within that temperature record. This graph is obviously restricted only back to about the 1880s, so it's the last 140 years or so, but you can see a continuous trend within that. Now, I suppose there could be an argument made at that stage that if you go back further and further, that climate change is cyclical, it is man-made, but equally there is something natural happening actually in the world itself, and that this periodically happens. That is absolutely true. Climate change does happen on a cyclical basis. But this graph, I think, paints that picture in a bit more detail. And as you can see, the temperature record here goes back just over or around about 800,000 years. You can see quite clearly that there are periodic changes in the Earth's average temperature, interglacials, glacial periods, etc. And these are to do with things like solar maximum, which you'll have heard before, the point where the sun's energy is most strongly affects the Earth. Effects like that undoubtedly will have an impact. However, you can see quite clearly from this graph that since the advent of the Industrial Revolution, and very much since 1950s industrialisation, we have absolutely been rocketing away. Our levels of carbon dioxide or carbon dioxide equivalent in the atmosphere at this stage are massive compared to at any time really that we've known before. Going back further than 800,000 years is obviously going to be very difficult to do from a data point of view. Mostly these temperature records are constructed by taking ice cores and analysing trapped bubbles of air from the very, very distant past. There's a limit to obviously what we can do with that. For the limits of our technology to be able to analyse how much of an effect we're having on the climate and on the Earth's atmosphere, this is it. I think this is, it kind of settles any debate you could possibly have about whether man is the driving force behind this effect, or whether this effect is in actual fact just a periodic part of the natural Earth cycle. So if we then accept that that's the case, we can start to look at where the greenhouse gases are being emitted from within human society. On a global basis, this pie chart represents quite roughly, I should say, where the sectors where greenhouse gas emissions are being emitted from. The largest of which is going to be heat production and electricity, so our own domestic activities, those sorts of things. There's a lot of humans, we like the lights on at home. Equally, how we've changed the land, how we're managing agriculture, but not just agriculture, forestry, land use in general, that is responsible for just under a quarter of all greenhouse gas emissions, which is a major thing. So globally, we can see that how we manage the Earth itself, the land's surface, how our industries that interact with that for food production, but also for timber, fibre, those sorts of materials, it can have a major impact. This effect is less for us in the UK and Wales, and I'll get to the Welsh specific ones in a second. It is true that they are less. Arguably, that might be because you could pose anyway that we have changed our landscape so dramatically in the last 150, 200 years since the advent of the agricultural revolution that if there was any deforestation to do, it's happened already, so we don't suffer quite the dramatic effects of, say, Brazil with neotropical rainforest deforestation and the effect that has on greenhouse gases. Nevertheless, agriculture and land use is a major piece of the pie in terms of greenhouse gas emissions. UK-wide, it's around about 10% of all emissions. So 1/10 of everything the UK does in greenhouse gas emissions terms is as a consequence of agriculture. I mean, that pales in comparison to transport. 28% of greenhouse gas emissions are transport. We like to fly and we like cars, but nevertheless, there is if we are able to amend how we manage our industry, then we can make a big impact on the greenhouse gas budget for the UK as a whole. In Wales, it's around about 12%. So we are obviously a little bit higher, but we are an agricultural nation in this respect. Food production is one of our biggest industries, whereas obviously the greenhouse gas emissions of London versus food production for the rest of the UK, it paints a very different picture. We're obviously very driven by ruminant agriculture in Wales as well. We are grassland and livestock. A lot of our landscape is what you would consider marginal land. It's where we can grow grass, but we would struggle to grow crops. And ruminants are excellent at turning energy from the sun and plants into usable protein in areas where you would struggle to grow food, marginal areas where food production would be particularly difficult to do. As a consequence, 53% of our greenhouse gas emissions for agriculture in Wales is as a consequence of ruminants. So that's a mixture of dairy cattle, other cattle, so beef cattle, and sheep. We then split it up as 21% for fertiliser. So obviously to keep a grass-based agricultural system working, we need to fertilise grass, and that has an effect on nitrous oxide or N2O emissions. Other agriculture, that includes poultry, pig, Horticulture, arable, etc. in Wales is only 16%. So you can see how little of that is represented in our greenhouse gas budget, and 10% is farm machinery. So tractors, combines, anything that you would run that is obviously going to be fossil fuel driven is going to have a greenhouse gas output. Breaking that down though, you can see immediately that if we're looking at around about 70%, 74% for just the ruminants themselves and the fertiliser needed to grow grass, that doesn't emit fertiliser for arable of course, but let's assume that the majority is going to be to grow grass here. If we can streamline how we're doing things, there's a big chunk of greenhouse gas emissions at a national level that we can reduce, and that is obviously an intriguing challenge. So what are greenhouse gases? Very quickly, I'll just touch on this, just because I think it's very useful to understand what we're talking about. We talk about carbon dioxide all the time. We know what carbon dioxide is, of course. It is a molecule which is made up of 2 oxygen and 1 carbon atom, with the carbon in the middle of the 2 oxygen atoms, essentially. It's the most famous greenhouse gas and the most potent. It has quite a long residence time actually in the atmosphere, anything up to about 100 years. So all that we emit, for all intents and purposes, for our lifetimes, is going to be up there unless we can find a way to actively draw it down. Methane, which is more potent, about 28 times as potent as carbon dioxide, is composed of 1 carbon atom and 4 hydrogen atoms. Methane, whilst is more potent, is 28 times as strong, has a vastly shorter residence time in the atmosphere, around about 9 years. So you can see that if you were to reduce the methane emission, which is one of the biggest outputs from agriculture, you could potentially have quite a meaningful impact on global atmospheric greenhouse gas concentrations in a relatively short space of time, without having to implement any major interventions such as new technology to essentially suck carbon dioxide out of the atmosphere. So I always think that's quite an appealing concept, because if we could find a way to change how we manage our livestock, i.e. if we could bring ruminant methane emissions down, then we could potentially see a genuine change in the short term. Lastly but not least, the last molecule that I'm going to talk about, and there are other greenhouse gases, but there's only 3 that really matter to us. The last one is nitrous oxide, which is 2 nitrogen atoms and an oxygen atom. And we get that mostly from emissions where nitrogen plays a part, so from fertiliser or from manure directly, something along those lines. It's much more potent than carbon dioxide, which is why we call things a carbon dioxide equivalent, somewhere in the region of about 300 times as strong. However, we emit it in vastly smaller quantities. Nevertheless, its potency does mean that if we can reduce it, then we can have, again, a meaningful impact. I'm just going to touch very briefly on how this mechanism works, just in case this is of interest to somebody and it helps to really set the scene. So greenhouse gases essentially are like a blanket around the earth. The more we have, the thicker the blanket. It works the greenhouse effect works in a really simple way, which is the sun's light penetrates the atmosphere and lands on the Earth's surface. Part of that light is then reflected back into space. The greater the concentration of greenhouse gases, the more of that reflected energy is captured in the atmosphere and the less escapes back into space. Obviously, the more you capture, the more you contain, and the more you're going to warm the Earth's atmosphere. But the easiest way to visualize it is the thicker the cloud of gas, the more particles of carbon dioxide, methane, etc., the thicker the blanket, the warmer the Earth's surface is eventually going to become. So, what are some of the impacts then of climate change on farm systems? If we come now to starting to look at how our systems are likely to change as the average temperature increases and the climate becomes increasingly unpredictable or more extreme, which is perhaps a better way to put it, we can expect certain challenges for our actual farming systems. Heat stress is going to become a larger thing. So animals are likely to suffer heat stress more and more. Equally, crops, grasses, plants that we would grow for food are also going to have to endure the same slightly harder conditions. There will be a greater incidence of things like pests and diseases. We know that there are a few pests and diseases that don't exist in the UK at the moment, that do on the continent or in more tropical regions, which, as our ambient temperatures warm and our climate becomes less inhospitable or more hospitable, then these organisms are going to find a way to the UK, at which point we are going to have to manage them within our typical farming systems. There are also perhaps potentially entirely new and novel pests and diseases which we haven't encountered yet that may get a foothold here as a consequence of the change in our ambient environment. We can expect there to be issues with our water supply. Water will become a more scarce resource. Obviously, if there is hotter weather, we will need more of it for irrigation or for feeding of livestock. Equally, rainfall is likely to become less predictable. We will see more intense rain showers, so we will get flood events, but not necessarily water that we can use. So it will be an unpredictable regime, and we will see extended periods of drought. So what we will see essentially is more intense rainfall over a shorter period, and then longer periods of rain-free activity. We may get a year where we see more rain than we've seen in human recollection for all records, and then we might get 4 years of drought. There is absolutely no way to know exactly what will happen with our localised weather patterns. All bets are somewhat off. The last point to make for how the impacts are going to change is we rely quite heavily on international food supply chains. So we rely on them for food that we buy ourselves from the shop, but equally within a farming context, we rely on them for livestock feed. This could present some really rather hazardous challenges for us as a nation. If food supply chains collapse and we are not prepared to feed our livestock as in a rotation within our farming system, i.e. by growing homegrown feeds, then we are exposed to these international supply chain vulnerabilities and volatilities. So that's the overview of some of the impacts. I think specifically, when we imagine the damage that's likely to come to us from climate change, we're not thinking about supply chains, we're immediately thinking about how the weather patterns are going to affect us. And it is entirely true that increased rainfall could have several effects that we're not necessarily anticipating. Obviously, we're going to suffer flooding, and that will have an effect on the forage provision that we can provide, because there'll be a direct impact to the fields, as well as to the quality of soils and things like that. We've seen that already in the last few years, that the incidence of flooding events is increasing and becoming increasingly unpredictable. Secondarily, there'll be effects such as, for instance, greater incidence of lameness or pests and diseases like liver fluke, which rely on soil moisture levels for their own reproductive cycle. These sorts of factors need to be considered. We need to start planning for how we're going to manage that within a farming construct, whether we have to have increased amounts of housing, whether stock have to come off the fields for the entirety of winter. So there are some things that we can do now to try and build resilience into our landscapes to make sure that as our weather patterns become more unpredictable and rainfall can do what it does and we'll get our annual flooding, then if we start changing towards, for instance, having permanent pasture as opposed to short-term lays, then we know that that has a positive effect on infiltration, water infiltration actually into the soil. Equally, increasing the presence of things like trees or hedgerows has the same effect. We know that that will get more water into lower levels within the soil and help that water to move through the landscape rather than sitting actually in waterlogged soil. Obviously, that's entirely landscape dependent. If you're on a floodplain, then you can plant trees forever. It won't make much of a difference, unfortunately. But for the landscapes where we can manage these things a bit better, we can just reduce some of the waterlogging in the soil, perhaps reduce some of the incidence of pests and diseases, some of the incidence of lameness, and overall as a nation that will have a beneficial effect. We can manage our soils better. We can reduce things like compaction or the breakdown of soil biodiversity, all of which will increase the degree of infiltration, once again, the water actually penetrating into the soil, running down earthworm burrows or otherwise. But all of these things have a positive effect, and they can all be done now. They are a best practice action right now. And if we adopt some of these practices, then we are going to start building resilience into our farm landscapes for future weather events that are likely to be increasingly unpredictable. We can also do things such as building vegetation actually into the landscape, so buffer strips across slopes to stop sediment being washed away into watercourses, potentially blocking those rivers downstream and increasing the potential for flooding events, but equally not losing the soil into the water. So if you're talking about really heavy rainfall events which are likely to break up soil crusts and wash nutrients and soil material away, then utilising woody vegetation across slopes and things like that, or on the banks of rivers, you will actually keep your soil in the field, which is the most precious resource we have. And we can adopt organisms which have deep rooting strategies. So grasses like Festilolium, which root much further down and will again help water to percolate into the lower levels of the soil.